When I first started working on Cassini, my daughter Jennifer had just started kindergarten, and now she's married with a daughter of her own. I've worked on the Cassini project for almost 30 years, and that's an entire Saturn orbit. Part of Cassini's success is really the tremendous international collaboration.
We had 3 space agencies contributing to this: NASA from the United States, ESA, the European Space Agency, and Aerospatiale Italian, the Italian Space Agency, all contributing hardware to this mission.
The beauty of Cassini is the design. It's the largest outer planetary spacecraft ever built. 12 different instruments brought from all over the United States and Europe. The Huygens probe, built by the European Space Agency. When you put all of that together, it's just a monumental machine.
3, 2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
We turned the Cassini cameras down to look at the rings, revealing them in a way we had never seen them before. I remember coming back to JPL early in the morning just so I could be there and watch those pictures one by one come down. And I felt like I could almost reach out and touch the rings that were right there. Basically tried to carry in our toolbox everything you could think of to explore the Saturn system.
We had been collaborating with the Europeans ever since launch to make sure that we had everything right for Huygens. The Huygens probe was dropped onto Titan. These are images from a billion miles away on the surface of Titan. It's just exhilarating. They're boulders, they're pebbles. We're in a dry lake bed. And I still get goosebumps just talking about it.
After everybody started getting their science, the beauty of what I saw in Cassini was they started collaborating with each other and saying, I have a picture of this part of Titan, what does your picture look like, you know?
Looking back at what we were planning to do in those first 4 years, we've gone so far beyond that.
We basically explored the whole solar system contained within the Saturnian system.
We remapped our investigations to concentrate on the questions that Cassini raised. The fact that there is interplanetary dust raining in on Saturn, and that collection of icy satellites and moons. The fact that we found subsurface oceans on Enceladus, which surprised everyone.
2 of our instruments actually sampled the plume of Enceladus as we flew through, tasting the gas, measuring the particles in a way that we hadn't planned. Cassini has changed the paradigm of where we might look for life. That will be one of her legacies.
13 years of exploring Saturn. It really is just an awesome mission.
A lone explorer on a mission to reveal the grandeur of Saturn, its rings and moons. After 20 years in space, NASA's Cassini spacecraft is running out of fuel. And so, to protect moons of Saturn that could have conditions suitable for life, a spectacular end has been planned for this long-lived traveler from Earth.
5, 4, 3, 2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn. We have cleared the tower. Its program is in. All program is in.
In 2004, following a 7-year journey through the solar system, Cassini arrived at Saturn.
Ground to the SOI burn attitude or pointing position and light up the rockets.
The spacecraft carried a passenger, the European Huygens probe, the first human-made object to land on a world in the distant outer solar system.
Huygens arrival on Saturn's moon Titan.
For over a decade, Cassini has shared the wonders of Saturn and its family of icy moons, taking us to astounding worlds where methane rivers run to a methane sea, where jets of ice and gas are blasting material into space from a liquid water ocean that might harbor the ingredients for life. And Saturn, a giant world ruled by raging storms and delicate harmonies of gravity. Now, Cassini has one last daring assignment. Cassini's grand finale is a brand new adventure. 22 dives through the space between Saturn and its rings. As it repeatedly braves this unexplored region, Cassini seeks new insights about the origins of the rings and the nature of the planet's interior, closer to Saturn than ever before. On the final orbit, Cassini will plunge into Saturn, fighting to keep its antenna pointed at Earth as it transmits its farewell. In the skies of Saturn, the journey ends, as Cassini becomes part of the planet itself.
The instrument acts like a human nose, analyzing the smell, so to speak, or the composition of the gases in the environment. There was a significant amount of molecular hydrogen. The existence of molecular hydrogen, at least within the Earth's ocean system, is like a food source. It's candy for microbes. They eat the hydrogen, they turn it into methane. And with our findings, we were able to not only find out that there was H2 in the system, but to examine the chemistry that's associated with that process of taking hydrogen and turning it into methane. Here on Earth, the hydrothermal systems, known as white smokers, have water-rock interactions that lead to the release of molecular hydrogen in a similar fashion to apparently what's going on at Enceladus. This is just the final step that shows that there's molecular hydrogen being produced by these same hydrothermal processes, and that molecular hydrogen has the chemical energy to support microbial systems in the interior ocean. It's not demonstration of finding life, but it shows the potential for the existence of life in this interior ocean.
In February 2005, we had our first close flyby of Enceladus, and the magnetometer signal saw something unusual.
What a magnetometer does is it measures the magnetic field in the vicinity of the instrument. We had a look at the wiggles, and they looked strange. The magnetic field of Saturn is moving towards it, and it couldn't penetrate down onto the surface, which was pointing to an atmospheric signature of some kind.
Here it looked like it had a tiny atmosphere. In March, we came even closer, looking for that same strange signal.
What it showed was that the signature, the atmospheric signature we were seeing, was focused at the South Pole. It was almost like there was a cometary plume of water vapor coming off from the South Pole.
People were saying, it's got to be jets, it's got to be jets. And the imaging team was saying, no, we don't want to say that, until we're sure. And so we went closer. We came within 175 kilometers of Enceladus.
Then we got the data back, and it was spectacular.
And then we found the evidence. Geysers coming out of the South Pole with water vapor and water ice particles. They were active geysers at the South Pole of Enceladus.
Because we were so close, all of the other instruments were able to take really good data. And we put together all of this data. We saw the cracks, the tiger stripes at the South Pole. We saw heat leaking out from these tiger stripes. On subsequent flybys, we found organic material, dust, water vapor coming out of the plume.
The Cassini discoveries in the first 3 flybys were so amazing. We changed our focus and added 20 more flybys of Enceladus, including 7 through the icy jets. The surprising magnetometer reading led us to the liquid water ocean underneath Enceladus's icy crust. After over a decade of research with Cassini, we now know there's a potential for the ocean on Enceladus to support life. And that has altered the way we think about where life might be found in our own solar system and in the worlds beyond.